Okay, hello, good morning, everyone. Welcome to UKBIC webinar number 4, which is introducing UKBIC new flexible pilot line capabilities. I'm Yahya Alvar, I'm Head of Business Development, and today I'm going to be your host. And the main speaker and main presenter today is our Chief Technology Officer, Richard LeCain. I will take you through a couple of slides about the webinar setup where you can ask your questions and give you a brief introduction about UKBIC. For those of you who have not been joined in the previous webinars and haven't got that much information about UKBIC, and then Richard will explain about flexible pilot line capabilities. The protocol for the webinar today is that please use Q&A on Teams to ask your questions throughout the presentation. If you have got any questions throughout the presentation, please raise questions there. We will give you some time at the end of the presentation to ask more questions. We will try to answer as many questions as possible. We have got also a guest from WMG, which will address the questions about WMG. If you would like to continue the conversation, or if you would like to get a bit more information, please contact us via sales@ukbic.co.uk or info@ukbic.co.uk. If you are a potential supplier and would like to talk about supplying machine materials, anything to UKBIC, please use supplier@ukbic.co.uk. And the last one, for your information, a copy of the slides and recording of the presentation will be available on UKBIC website and also on LinkedIn from Friday, 7th of February. The agenda for today, as I explained very briefly, is very quick introduction about UKBIC capabilities in general, and then a bit more in depth introducing about UKBIC flexible pilot line capability, which will be up and running around Q3 this year. So UKBIC, so many of you already know UKBIC is part of the Faraday Battery Challenge, which was £610 million challenge in the last 8 years time frame to focus on research, development, scale up and industrialize anything about battery and develop the battery ecosystem in the UK. Initially, £130 million invested in the facility to build a scale-up facility to support product development and process optimization for different customers. And more recently, we had a bit more investment in the facility and installed different capabilities and improved our capabilities to offer a bit more support for different range of customers with different range of requirements. We are based in Coventry, next to Coventry Airport. So the initial idea was that UKBIC should be supporting customers who have got their developed product ready, and they are around TRL 7. TRL 6, TRL 7, the idea was that we had to support customers to scale up their products, to optimize battery manufacturing processes, and help them to be ready for giga-scale manufacturing. So the whole idea at the beginning was that UKBIC should bridge the gap between university scale, gram level scale product development and giga-scale volume manufacturing steps. But in the last 4 years, we have realized that many of our customers are sitting at a bit lower TRL and a bit lower MRLs. And for that reason, further investment required to bridge the gap between lower TRL, lower MRL, and where our current capability is. For that reason, flexible pilot line came to play, which will cover TRL 4, TRL 5, TRL 6 stage, and I'm sure that Richard will cover that. UKBIC currently has got Anode manufacturing, cathode manufacturing at giga scale. We also offer cell assembly for two different type of cells, pouch cells and cylindrical cells, 21700 cylindrical cell and 300 by 100 pouch cells. We also offer formation, aging, and testing for both cylindrical and pouch cells. We also offer agile module and pack build facility, including end-of-line testing. The whole idea about module and pack is that we deliver and develop DFA, DFM, and help customers to understand how they can automate their manufacturing processes to achieve higher throughputs and lower the risk. We are open access facility to anyone who would like to develop anything around battery technologies. We do different trials, we do different product development runs, and the most important here is that we don't want to maintain or retain any IP from any customers. Any background IP that customer has is customer IP, and any foreground IP we created throughout manufacturing processes at our facility is also belonging to the customer. And that is on its own is a very unique business model globally. We also supporting customers to train, to upscale their engineers, their operation people, and maybe just transfer the skill set from where they are into battery manufacturing area. About the industrialization scale-up line, the line that we currently have is at volume scale battery manufacturing equipment that you can find them in any giga facilities around the world. This facility, again, is a development facility we designed to be very modular. Different customers, they can start from different part of the line. For example, if you would like to start from coating and you don't want to share your mixing IP, you can give us ready mix slurry. As long as it is compatible with our line capability and capability limitations, we are happy to take that slurry and push it into the coating line, drying line, and make coated material. Or if you give us coated electrode, we can push them into our calendering line and start calendering the material. For that reason, our facility is very flexible, is very modular. Our processes currently covering equipment and processes covering end-to-end the process from electrode manufacturing into cell assembly, formation, aging, testing, and then we can move those cells into module and pack build facility. To that extent, it is one-stop shop. And we have got the baseline cell design for both cylindrical cells and pouch cells. We can work with different customers to use the same platform as a baseline to benchmark their own technology, and then they can see the journey and how they can improve their cell performance against the baseline cell. As I mentioned, we have realized that we need a bit more equipment and investment to bridge the gap between where we are and where most of the customers sitting right now. For that reason, £74 million invested again via Innovate UK and Faraday Battery Challenge in our facility. We installed flexible pilot line, which Richard will explain about it in more detail. We installed new battery lab, which is operational right now and has got 5 different sections. We presented at new battery development lab in another webinar. Again, the slides and recording is available via UKBIC website. If you have got further questions, please get in touch. And we also installing new clean and dry rooms, which would be available very soon. And the idea is that we share those clean and dry rooms with different customers and do co-development with different customers to help them to go to market much sooner and much faster. This is just very brief explanation about what UKBIC has already and what we offer currently. And I'm going to pass it over to my colleague, our CTO, Richard LeCain, who will explain about flexible pilot line. Please, Richard.
Great. Thank you, Yahya. Thank you for that introduction. And thank you for everyone who's joined the call today. I know your time is at a premium, so we appreciate you joining the webinar today. I'm Richard LeCain, the Chief Technology Officer at UKBIC, and I'm going to introduce UKBIC's new flexible pilot line today. So what is flexible pilot line, FPL? It's, as Yahya has been talking about, there's a need to bridge the gap between smaller scale chemistry and cell development and industrialization. The gap today is for early production quantities between the hundreds and thousands. We have facilities in the UK like WMG, and we're pleased to have the chief engineer from WMG on the line with us for the Q&A today, Rob Brewer. I'll be speaking to you later. The WMG facility is geared towards chemistry and low quantities of cells, early stage development prototyping. The industrial scale-up line that we have at UKBIC is more geared towards hundreds of liters of material and thousands of cells. So to bridge that gap, the FPL is being installed at UKBIC to streamline that journey from early stage prototype to industrialization. Today, we're going to be talking about the electrode side of that. That's the first part that's being installed now. Currently, equipment's coming in and will be commissioned this year. The cell assembly part of the flexible pilot line is going to come on after. So today, we'll be talking about the electrode development side of the flexible pilot line. And we, as Yahya mentioned, we do have the capability to build cells on our industrial line here. It would be possible to take an electrode off of the flexible pilot line and run it through the industrial line. So FPL is a space for executing early stage optimization cycles and production trials to demonstrate products. The line will accommodate multiple solvents, chemistries, and cell formats. We think this is an important point as the industry goes forward to be able to accommodate different chemistries, which may include different solvents. So the mixing area and the coating area will be able to handle more solvents than what's traditionally used in electrode manufacturing, which is water and NMP. It bridges the gap between UKBIC's existing industrial scale-up line and other kilogram scale demonstrator lines. So what does the flexible pilot line provide? What it has is some zones. There are 5 zones, each capable of minus 40 degrees Celsius dew point, allowing a controlled environment in each area. There are secure material airlock access points which protect customers' intellectual property at each point. So there are multiple entries into the areas. So traditionally you may gown up in the mixing area and have to go through the whole thing. But if you're a customer here and working in a specific area, we can segregate that and we can wall off access to certain areas so that your intellectual property remains secure. So it offers developers early access to industrialization and a flexible approach for developing electrodes. I think that one of the biggest points of this is the low cost, efficient, and quick turnaround and low quantity of material for entry to use these lines. Like we've been talking about, the step from a smaller, earlier prototype line to the industrial scale-up line is very large. And to run a campaign on industrial scale-up line, you're talking hundreds of liters of materials. That's a lot of cost of materials when you're talking about NMC and binder and conductive additives. So being able to use a smaller volume of material and run that online and get good actionable data out of it in a controlled environment is something that we think is going to be really valuable for companies that are trying to industrialize. So you have access to all that new high-tech manufacturing line that we're going to be talking about in the slides coming up. And this allows the scale up from lab to production environment. All right, and with that, I'm going to show you an animation about the line, and we'll explain a little bit more of the details of that line, and we'll talk a little bit more in depth about what's in those rooms and what those equipments are capable of on the other side. Terrific. Great. So hopefully that gives you a little bit more in-depth look at what the FPL is. And so we'll talk about that on this slide. So what you just saw was the animation of what that line is going to be. And so here's what's included, which some of the things you just saw. So talk about 5 zones controlled to minus 40° C dew point. An anode and cathode mixing area. I mentioned an area to be able to mix low flash point, solvent material, and conventional solvents. And then the coating area, calendaring, slitting, a dry lab, which we'll talk about, and then the areas for future cell assembly that I'm sure we'll have a future webinar about. So let's dig into the different areas and what they're capable of. In the mixing area, 2 mixing lines in a clean, dry environment. So the intensive conventional solvent mixing area, 15 liters up to 45 liters, and the low flash point solvent mixing line, 15 liters up to 45 liters. There will also be an extrusion mixer there, so a continuous throughput mixer. I think a lot of facilities are looking at bringing on this capability, and this would be a place where you'd be able to come and trial that type of mixing if that's what you're looking to develop. So a 20 liter per hour continuous mixing process will be installed as well. There's an electrode process development area. This is a much smaller coating line to look at electrodes. So a couple of small mixers, roll-to-roll coater with a slot die in it with a 1 meter dryer. This is to help develop coating processes as you go forward. Separate anode and cathode processing areas and allows for safe use of powders and handling of emissions. Looking at the coater, it's a very good, capable Mathis coater. It's a single-sided coater, 6 meters of drying slot die. Since we are mixing multiple solvents, this can handle multiple solvents in the slurry. It's capable of 320 millimeter width. You could do intermittent stripe coating, continuous coat patterns. You could gear this down to about 0.5 meter a minute line speed, and is capable of much, much higher than that. So a wide range of capability for developing coating processes to get ready for scale up, or scaling that up to get into the industrial scale up line. The calendar is a InjaCal calendar, so very lots of capability on this as well. So an SRAP web path for roll heating. So the web can be heated before it enters the calendaring rolls. Calendaring rolls can be capable of 150-degree Celsius temperature. It includes web cleaning and edge trim functionality. Along with the fact that we can heat it, there's also a cooling roller at rewind to take heat out of that web as it's rewound. Inline thickness measurement and surface inspection. It's a 220 kilonewton calendar that can support 430 maximum web width, and of course we can calendar intermittent stripe, continuous, or asymmetric coating patterns. And on the slitting side, this is capable of 500 millimeter wide webs. It is capable of 80 meters a minute, but can be geared down considerably below that if you're dealing with smaller amounts of material that need to be slit, and includes dust extraction as part of the line. And the last room that we'll touch on today is the dry lab. This is complementary to UKBIC's new battery development laboratory, which we had a webinar on last month. It's a very capable lab. It's designed to support customers that are on site, that are going through that industrialization journey. As you do that, there are things that you need to find out about electrodes that are being processed. So we have SEM, FTIR, ICP available along with lots of other pieces of equipment in there. I won't go through them all, but you can look in our website. There's a link to the webinar that we did on that last month. But this is an area that is designed to support small-scale mixing and coating with companies that are using FPL or using the industrial scale-up line. So it can assemble small coin cells, small pouch cells. There's a small mixing capability and drawdown table, and the ability to make small cells to be able to look at materials more closely as you're working on equipment at the FPL or the ISL. So just to run through a quick summary, and I know it was pretty quick, and we're just talking about the electrode side capability of the line today that complements the industrial scale-up line and makes that bridge between smaller scale prototype development at WMG. This gets to the next stage before the industrial scale-up line. So more organizations will get the opportunity to scale up their battery manufacturing using the new line at a lower cost of entry than the industrial scale-up line. Again, I think that's a key point here, is that the amount of material that is needed to run on the flexible pilot line is much, much less. We're talking 15 to 45 liters of material versus 150 liters plus on the industrial scale-up line. So you can just understand that the buy-in to be able to get on that path to industrialization has been lowered a lot. space for executing early stage optimization cycles and production trials to demonstrate your products. FPL supports validation and commercial activities. So I think that if you want to put this in terms of cell development that we talk about a lot, this is a line that really gets you from a mature A sample through the B sample stages before you get to going into that process validation stage at the industrial line. It's designed to ensure product quality and demonstrate repeatability. So we're getting at that through the environment that we're going to have. It's a dry environment. It's a clean environment. So you'll be able to generate data on good, reliable machines and actionable data that you'll be able to take with you and have confidence in. And it's the ability to learn quickly using known equipment and technology. And so with that, I'm going to thank you for listening to what the flexible pilot line is. And again, thank you everyone for taking time out of your day to join this call and understand the new capability that we're going to have online. We're bringing mixers in right now. We're doing factory acceptance tests. And we're building up this capability now. So I'm going to let Yahya take it over again and talk about what's coming up next.
So thank you, Richard, for a very good presentation about flexible pilot line. The next one is about the Q&A session. We already have got few questions that I'm going to ask. And that is also another opportunity for you all. If you have got any questions, by all means, please use the Q&A function on Teams and raise your questions. Richard, the first question is very interesting question. Is about sorry, if you wouldn't mind, I'm gonna not read the name of the person who actually asked the question, but this is a general question that maybe everybody else might have. What impact do you see the FPL having on the UK battery manufacturing landscape? And how do you envision the UK's role in the future battery production?
Thanks. Yeah, that's a great question. And I'll also point out that we do have on the line Rob Brewer from WMG. And I think a point that I didn't touch on earlier, and I really should have. And Rob will be here to answer some questions if there's anything specific to WMG. But WMG is a partner in this, and they're actually going to have people working on the line here. So it's a joint effort between UKBIC and WMG. So there will be UKBIC personnel, WMG personnel that will be helping to run the flexible pilot line at UKBIC alongside workers who are part of UKBIC. We think that's really important to strengthen the battery ecosystem and to have that link again between early stage prototype, technical readiness levels in that 5 to 6 area, and then above that into industrial scale-up line. And if I remember right, I think the question was actually around the impact FPL having on battery manufacturing landscape in the UK. So the FPL, will bridge the gap between R&D and commercial scale battery production. By enabling the UK to manufacture batteries at a semi-industrial scale, it will give manufacturers a chance to refine their technologies, test innovative designs, and streamline production processes without the high costs and risks associated with the full scale-up line. This will directly contribute to enhancing the efficiency and scalability of battery manufacturing in the UK. One of the key benefits of the UKBIC FPL is that they help to support a localized battery supply chain. So by enabling the scaling of innovative battery technologies, developing a robust supply chain, creating new jobs, and contributing to sustainability goals, the UK, it puts the UK on track to become a larger player in battery production. So thanks for that question. That's good.
Yeah, thank you, Richard. There is another question here. The question is about, I believe, the cell size. I was wondering how adequate the FPL is for 18650 cells versus 21700 cells.
In the current incarnation of the FPL, so like we said, you would be able to make electrode on FPL and potentially run that electrode through our industrial scale-up line, and that's a 21700 line. What we make here are 21700s and 300 by 100 pouch cells. We don't run 18650 here though, and so I don't think we'd be capable of making that. But in cylindrical format, we could run 21700 cells.
With the smaller format cells.
Another question is about electrochemistry. Is UK set up to support LFP or LMFP cell development?
Sure. So in terms of flexible pilot line and LFP, there would be no problem running LFP through that line. I think the same, I'd probably say for LMFP as well. If you're looking for materials that need a dry environment, we'll have -40°C dew point capability on those lines in a clean environment. So running LFP shouldn't be a problem.
Okay, thank you. The next question is about dry mixing. The mixing area is shown to have some capabilities in small-scale dry electrode mixing. How about the coating area? What is the capability of FPL in dry electrode coating?
Yeah, that's a really good question. So currently the FPL so we're looking at FPL as the bridge between we say early stage cell prototype and industrialization. So that path right now is coating, I guess slurry-based electrode coating and drying. We are going to have the continuous mixer to do continuous throughput mixing, but in terms of dry coating capability, that's not something that we're looking at for FPL right now. What I can say is that we do see that as an important part of the industry going forward. And one of the things that we have at UKBIC that we're building right now are clean and dry zones. So they're separate from FPL. And these are areas where customers could install their own equipment or do their own industrialization research and use that area to develop capabilities like dry coating. But as far as the FPL is concerned, that is not in the scope right now.
Thank you. Another question about prismatic cells. Are there any plans to support prismatic cell format in the future?
Good question. So we're capable of in terms of stacked cell assembly, capable of doing pouch cells at UKBIC. And we talked about the electrode side manufacturing today, and we'll have another one when we talk about the cell capability, the cell building capability that we're going to have in FPL. And I think some of that hasn't been totally sorted out yet, but at a small scale, what we're finding is in terms of prismatic can be a bit difficult to remain flexible and have prismatic, because you inherently have to have a single form factor of prismatic can. And so unless we want customers to be able to come in and make different types of cell formats. And so if you're looking at prismatic, you're kind of hemmed into that one prismatic can, and decreases the flexibility of what the flexible pilot line is intended to be.
Thank you. Another question is about, can you shed some light on how industrial partners, cell manufacturers, or automotive companies take advantage of the FPL in terms of developing new material and new cell designs?
Sure. And this will be, maybe, when we get the webinar on the cell assembly side, that this question will be even more applicable. But I think for automotive customers, if you're on that journey of A sample into B sample into C sample, and you're trialing different cell chemistries, and you're trying to figure out how to process them and how to scale them up, that's exactly what the flexible pilot line is for. Different types of cell chemistries, if you have different additives and you have different binders, or you have just different requirements for making electrodes and then making cells, figuring out what your path is from where you are through design validation. That's what the flexible pilot line is designed to do at a lower cost of entry. So if you're in automotive and you're working at a certain scale, and sometimes you don't have all them, you don't have access to large volumes of material. So using the FPL is a good pathway to learn a lot about your cell chemistry, learn a lot about how your materials process, and learn a lot about how they're going to scale up. And then get to that mature B sample level, and then into the C sample level.
Thank you, Richard. There is another question about the quantity of the pouch cells that we can produce. The question is saying that what would be the minimum quantities to assemble pouch cells that we accept?
Minimum quantity. Another one that's going to be interesting as we build out the cell assembly area. It's right now, if you want to run material on the FPL and then get it to the industrial scale-up line for pouch cells, we'd probably have to run about 300 meters, I'd say, for that to be a relevant test. We could probably get away with a little bit less, and with yields, probably yield enough material to make a relevant experiment. But without getting myself in too much trouble and marrying myself to too many numbers, I'm thinking that's probably the area that we're thinking of. But with a 6 meter dryer and a 45 liter mixer, that's something that should be doable.
Okay, thank you again. So the next question is about the timeline and fundings. And the question says, could you please provide some detail on timeline and possible funding opportunities to support SMEs to get access to the flexible pilot line?
Sure. So we're probably looking at about Q4 for customers to be on the flexible pilot line. We'll be commissioning and doing acceptance tests through the summer. But we're probably looking at about Q4 for customers to be able to access the line.
Okay, thank you. The next question is about almost comparison between flexible pilot and other lines. The question says, what will UKBIC's flexible pilot line can do that other lines cannot?
That's a good question. So, if we take WMG as an example, the focus there is on research, getting the chemistry right. What the FPL will allow us to do is to take that research and see what happens when you scale it up. So WMG might be producing 20-ish cells a day, while FPL is producing 100 cylindrical cells or 50 pouch cells, and seeing whether the chemistry developed at WMG works at scale and what the other questions are that need to be answered to be able to get it to work at scale. The hope is that customers then go on to the industrial scale-up line to test their designs at gigascale, where we can produce 20 cylindrical cells a minute. It's very much a progression as we see our customers see exactly what happens when mixes get bigger, how the materials coat, and whether we can make effective cells at scale. It's very much going from the research lab to a manufacturing line.
Thank you, Richard. I believe the next question is for you, Rob. This one is about WMG and UKB collaboration, and it says, how will UKB and WMG contribute to countries' competitiveness in this sector with FPL, with new flexible pilot line?
So that's quite a broad.
You're on mute, I guess, Robert. Sorry.
Sorry, I shouldn't be on mute. Can you hear me now?
No, we can't hear you.
Nope.
Yeah, now it's well, I think I understood the question. Yeah. So we'll see if
you wouldn't mind, Richard.
Yeah,
please,
if Rob gets his mic up and working, but I think it was around UKBIC and WG contributing to competitiveness, I think, in the sector with FPL. So I'd say UKBIC and WMG's involvement in FPL, helps bridge the gap between research and large-scale production. The line was created to improve the UK's ability to meet the growing global demand for high performance, lower costs, sustainable batteries, while also strengthening its position in a key sector for that's critical for the transition to a green economy, including EVs and renewable energy systems. So ultimately, this will support the UK's competitiveness on the global stage as the battery market continues to grow.
Okay. Thanks. The other question is about solid-state batteries. Is there any plan on supporting the all solid-state battery development at UKB?
So another one that's maybe out of scope for flexible pilot line, because we're industrializing cells from along that TRL stretch. So lithium-ion cells that we're looking at slurries and coating and building cells. But again, we talked about the clean and dry zones that we're building up at UKBIC, and having that available here. If there were companies that wanted to work on solid state chemistry, that might be a place to bring in capability there. I will say that we do have customers that they're working with us on the industrial scale-up line that are in the solid state area right now. But in terms specifically FPL doing solid state development, that's out of the scope for what we're doing there.
So I believe the technical issues with Rob microphone is now fixed. We could technically hear you, Rob. I'm going to ask you the next question about WMG. How does WMG work with flexible pilot line to help bridging the gap between academic research and real-world manufacturing?
Can everyone hear me? Just checking.
Yeah, we can hear you now. Yeah.
Right. So the plan is that WMG and the FPL facility specifically will work in tandem to create a more integrated ecosystem for SMEs and small businesses to enter into the batteries value chain. So WMG and the team at FPL will work together. So WMG staff will use the flexible pilot line in tandem with UKBIC staff. The intention there is to create a seamless transition as best we can between small scale work on the kilograms to tens of kilograms scale, tens to hundreds of cell scale into the flexible pilot line facility. So the intention there is that we're trying to construct an ecosystem that would allow people to scale rapidly and quickly between fundamental R&D, intermediate materials and process development, all the way through into much larger scale processing tools.
Okay. Thank you, Robert. The other question is about what role does UKBIC play? Maybe this one is for us, Richard. What role does UKBIC play in educating and training the future workforce for the battery manufacturing sector?
Sure, thanks. So UKBIC plays a role in the education and training of the future workforce for the battery manufacturing sector. We have a L&D group on site here, and by offering practical training, industry certifications, supporting apprenticeships, collaborative educational initiatives. UKBIC helps equip individuals with the skills needed to thrive in that type of field. Moreover, by bridging the gap between academic research and real-world manufacturing, UKBIC can help ensure that the workforce of today is ready to meet the evolving demands of the battery industry and contribute to the UK's competitiveness in battery production.
Okay, so the next question is also a very interesting question. Looking ahead, what are the next steps for UKBIC and what future development or expansions we should expect to see in the coming years?
Good question. So I can say that the flexible pilot line, it's part of a £73 million investment from UKRI, which also includes the battery development lab, which we talked about, which is already operational. Some already available cell cyclers, which opened last year, the new clean and dry zones, which I've been talking about, which once open will provide dedicated clean and dry room environment for customers and suppliers. In addition to that, there'll be lots of training opportunities in our existing industrial line.
Okay, so there is another one. I believe you already addressed this one, but this is another one, which is the last one, I guess, is when the customer would be able to use the flexible pilot line.
Right. So like I said, we're actively talking to relevant customers, both nationally and internationally. So, the UK Battery Industrialization Center is not just for UK. It's open internationally. There's a very high level of interest in using FPL. I mean, that was the reason that we built our building FPL. It's our feedback from customers was WMG is great. We love working at WMG. They do really good work. They get us to a certain scale. UKBIC industrial line is great. It gets to a high scale, but it's a very big leap going from WMG into UKBIC. So, we're close to finalizing some deals with customers. The benefits of using FPL are getting access to that new high-tech manufacturing line with quick turnaround capability, high quality electrodes, low cost and efficient, the opportunity to, see products develop from an early commissioning stage, scale up from the lab to production environment with uniform coding quality, and doing that tech transfer so you can generate data that is actionable.
Okay, thank you very much. For the next question, I will address this question myself, if you wouldn't mind. This question is about, will there be any similar webinar for Agile Module and Pack and maybe for testing facilities? So thank you very much for that question. Technically, the answer to that question is the next slide, which is webinar number 5. Introduction to UKBIC's module and pack capability. We plan to have this webinar on 5th of March. We will share more detailed information via UKBIC website and our LinkedIn page. Please follow us and be ready for that webinar. We appreciate your time and your interest to join to that webinar too. Again, I will host that webinar and my colleague Andrew Britton will explain a bit more in detail about our module and pack capability at UKBIC, including end-of-line testing capability. And I can't see any other questions here. I'm guessing that we have addressed all these good questions. I'm going to say thank you very much for your time. Thank you very much for listening and very good questions. And we also appreciate Rob for your time and answering the WMG questions. We had a little bit of technical issues on the first question. We couldn't hear you properly, but it just fixed for the second question. Thank you, Richard, for your presentation and answering the questions. If you have got any questions or any would like to get any further information, by all means, please contact us either via UKBIC sales or info email box, or contact us directly, and we are more than happy to help you, to support you with any new product development processes or process optimizations that we can help you with.
Thank you, everyone.
Thank you.
Thank you, everyone.